Uh, Hello and good morning, good afternoon, good evening, whenever you're watching this video. This is Mr. Hill again with some more science. We're talking about solubility rules, as in the rules that help dictate what can be soluble and not be soluble. Everything is not soluble, not all ionic compounds. So, our favorite one, salt, for example, sodium chloride, we overuse a lot. All of those, like that compound, are not soluble or dissolve. Instead of doing experiments all the time, we can actually use rules to help us determine what is what because experiments are expensive. We may not always have the time or the opportunity to do the experiments. So here are some rules about it. Number one, all nitrates are soluble. And you can get a list of these, by the way, as far as nitrates, and also all ammonium or alkaline metals or compounds are all soluble as well. All carbonates, that's things like CO2, for example, no, CO3, phosphates, hyd- hydroxides are insoluble except with the cations in Rule 2, meaning that if you do have a hydroxide and it has something that's alkaline, ammonia in it, it would be soluble. All chlorides, bromides, and iodides are soluble except for lead, silver, or mercury, not magnesium, mercury, Hg, mercury. My apologies. All right. And then number five is that all sulfates are soluble except for the ones with the following elements as calcium, strontium, barium, radium, and lead, which is soluble in this example here in terms of water. Let's look at a few. So we have SrSO4, strontium sulfide, and that next one is sodium sulfide and lead chloride. Let's see. The first one's not soluble. The second one is soluble, and the last one is not soluble. So if I look at the rules that we used previously, you will actually be able to see how they came together. And so how we know? Like dissolves like, meaning that water is polar, so most polar compounds dissolve in water. Things that dissolve in water, soluble ionic compounds. You can use table F. The You can use table F as a resource, but I don't think we're going to get into the table F resource just yet, but we will later on, or a different one that's a likened to it. Also, acids that start with H except for H2O or H2O2, which is H2O is water, and also H2O2 is hydrogen peroxide. Except for HCl, bases, metal, and OH and H3. Example, you have sodium hydroxide, OH is hydroxide. Polar covalent molecules. Remember, polars have poles, non-polar have no poles. So think about North Pole and South Pole. If you think about a compass, you have North and South. The North and South poles on the compass is similar to that of North Pole to the Earth, South Pole to the Earth. And those poles let us know the directions of the flow of electromagnetic fields, which we may get into a little bit later. Not sure. All right, let's move on. All right, my apologies. I'm not sure what happened there. All right, perception, precipitation reactions. When a solid does not dissolve, it is called insoluble, and that solid forms when you have a reaction or a chemical reaction to be exact. It's called precipitate. Now we do watch the news, or those that do watch the news, and you may look at rain. You may look out for snow or hail. Hail is pieces of rock, ice that look like rocks coming out the sky, and those pieces of ice will come down and do a lot of damage to people's cars and windows. And I used to experience that quite a bit when I lived in Colorado. We used to get hailstorms that may occur during the fall around this time. You may have 60, 70-degree weather, and you look up at a picnic, you'll start seeing rocks come out the sky, and it is actually ice rocks, rocks of ice to be exact. That is what hail actually is. And I've actually got hit in the head one time by one of those, and it actually was very painful. So just give you an idea. But precipitate is something that forms as a reaction. So if we look outside, even today, depending on where you are in the Midwest, you might have snow, you may not. But just like the weather forms a precipitate, so does chemical reactions. So when sodium chloride is formed, the crystalline structure that's formed after that reaction of sodium and chloride, excuse me, chlorine, is the sodium chloride, and that is precipitate. For example, you can predict the products of the following reaction if you can follow which one will form precipitate and which one does not. So this is one dealing with a lead nitrates in water, and it's actually being interacted with potassium iodide, appears to be, and it forms a lead iodide and also potassium nitrate. And we know it's a solid precipitate because it's insoluble according to the rules. Something that's soluble, meaning it's not dissolved, is going to form as a precipitate at the bottom. Some pronounce precipitate or precipitate. You may hear both. Here's a picture of a chemical reaction. And what we have here is the reaction where you have the lead in a container with the nitrates. And you also have it a container where you have the potassium and iodine, excuse me. And when they two interact, the precipitate is formed is the lead iodide at the bottom, right where the circle is. And you still have the nitrate and the potassium still in the container even after the reaction. That's because the NO3, which is nitrate, and the K, which is the potassium, are called spectator ions. They do not interact in the chemical reaction. They're just there, present. But then you have the lead iodide that's formed at the bottom. They're called the ionic. Uh, they part of what's called the net ionic equation or the net ionic interaction, where these things are the ones that do all the interacting in the presence of the container or the water or aqueous solution, if you will. And here's another example or definition of that. A net ionic equation shows only the ions that are involved in the reaction. So it's not going to show anything else except for those who actually involve what's going on. Now we have a classwork assignment, which is simply called What is Soluble? And what it is going to involve you reading some links and actually writing a paragraph. And there's more instructions on that inside the assignment. Now, if any questions, feel free to contact me through Schoology or my email, jhill@lakelandlakers.net. And with that being said, thank you for watching and have a great